Let's take a look at theorem number 7, which states that a diameter perpendicular to a chord bisects the chord and its arcs. Although I'm not going to do the first proof, I can show you using the diagram what the theorem means. We have diameter ST. If we know that it is perpendicular to chord PQ, meaning that we have right angles, that means that the diameter bisects the chord. So chord PQ is split in half, so PR is congruent to QR, but it also bisects the arc PQ. So arc PT congruent to arc QT. So let's try number 2. It says that we have a radius OC is 5. I'm going to wait to put that into the diagram. We also know that chord AB is 8 centimeters and it's perpendicular to OC at point P. So right away, using the theorem, because it tells you that the chord is perpendicular to the radius, we know that chord AB is bisected. It's split in half. So if the chord was 8, we can mark in that each half is 4. What is the length of OP? So I'm just going to label that side as X. Well, what you want to do here is you want to connect from OB, which is a radius of the circle. And because it's a radius and OC was a radius, it's also a length of 5. I'm going to just trace here. If you can tell, I formed a right triangle. And we know 2 sides of the right triangle, 4 and 5. We don't know the third side, X, which means we're going to use the Pythagorean Theorem. A squared plus B squared equals C squared. The hypotenuse has to be the C, so the side across from the right angle, which is 5. The other 2 sides are X and 4. 4 squared is 16, and 5 squared is 25. Subtracting 16 from both sides, we have x squared equals 9, and taking the square root of both sides, we get x is equal to 3. This is what we're going to do for the next few problems as well. So I'll show you one more here. Number 3, we have diameter DB is perpendicular to chord AC at E. Again, we're going to be forming a right triangle. We don't really know yet which side it's going to be on, so just put in the right angle, and we can always just add it to the other side if that's where our triangle happens to be. If DB equals 26, I'm just going to wait to label that in the diagram, and AC is 22, what is the length of EO? Let me put an X. Or in simplest radical form. Okay, so let's use the theorem. The diameter is perpendicular to chord AC, which means it splits chord AC in half. If the chord was 22, we know that it would now be 11 on each side. Forming the right triangle, it actually doesn't matter if you connect from O to A or O to C, but you're just drawing in a radius. So draw in the radius. Okay, you can see here, I'm just going to trace the right triangle. And we do know the length of OC. We can find that. It told you that the diameter DB is 26. Well, half of the diameter is a radius, so half of 26 is 13. Therefore, since OC is also a radius, that side is 13. Pythagorean theorem again. This time across from the right angle, the hypotenuse, the C is going to be 13, and the other 2 sides are X and 11. So 11 squared is 121. 13 squared is 169. Subtract from both sides, and you're going to have x squared equals 48. And we're going to take the square root. Now at this point, you are going to have to use the perfect squares list because it says simplest radical form. So 1 squared, 2 squared, 3 squared, 4 squared, 5 squared. I'm just going to up to 6 squared because I know that's enough. The largest perfect square that divides into 48 is 16. So I make 2 radicals, the perfect square going first, 16. 16 times 3 is 48. The square root of 16 is 4, and we're going to leave the 3 underneath the radical. Let's talk about one more theorem here. Theorem 6. It says if 2 tangents are drawn to a circle from the same point, then the tangents are congruent. I'm actually going to show you number 7 first. So it tells you that you have tangents CA and CB. You can see that they're drawn from the same point C. That means C to A is congruent to CB. And I just formed an isosceles triangle. The question asks, what is the measure of angle CAB? Well, in an isosceles triangle, the base angles are congruent. So by the triangle sum theorem, all the angles in a triangle add up to 180. I can subtract that 30 degrees. So we get 150 divided by 2, and the base angles are both going to be 75 degrees. All right, let's move on to number 6. We have triangle ABC is circumscribed about circle O. So that means that it's on the outside of the circle, touching it in 3 points. and the sides of triangle ABC are tangent to the circle at points D, E, and F. AB is 20, AE is 12, and CF is 15. What is the perimeter of triangle ABC? So we have to find the sides of triangle ABC and then just add them up. We know one of the sides is 20. In order to get the other sides, you're going to have to use the theorem 6. So if you look at point C, from C to F is a tangent, C to D is a tangent, and they're both drawn from the same point C, so that means CD is 15. We can use the theorem again. AE is a tangent, AD is a tangent, both drawn from circle point A, so AD is 12. Now to get the tangents in the top, both drawn from B, they are congruent. If this whole side is 20, AE is 12, 20 minus 12 gives us 8, and using the theorem one more time, we know that BF is also 8. So now to get the other sides of the triangle, we just have to add 8 plus 15 is 23, 12 plus 15 is 27, and if we add the three sides of the triangle, 20 plus 23 plus 27, to get the perimeter, we get 70. One more question using this theorem. Number 8. PA is tangent to circle O at A, and PB is also tangent to circle O at B. Now you can see that both tangents are drawn from P, so that means PA is congruent to PB. The length of PA is 6, that means PB is also 6, and AO is 4, which AO is a radius, so that means BO is also 4, being another radius. Find the measure of angle POB. Well, you can see it kind of splits it in half, so we have a triangle here. Well, using another theorem, when you have a tangent drawn to a radius, you get a right angle. They are perpendicular. So that means angle A is right angle, and angle B is also right angle. So now we specifically have a right triangle, and we're going to focus on the bottom triangle because of the angle we want to find. If we're trying to find an angle and we have a right triangle, this is going to be a trigonometry problem. So we have to use SOHCAHTOA and figure out which trig function we're going to use. Okay, so across from your angle, that's the opposite side, so 6 is opposite. Next to your angle, that's the adjacent side, which is 4. Whoa, okay, I don't know what happened there. It's like a major delay, it wouldn't let me write. Adjacent, so opposite and adjacent is tangent. So tangent of theta equals opposite over adjacent. Theta, we don't know, so you can just leave it as theta, that's fine. You can put an x in there if you want to. The opposite side is 6, the adjacent side is 4, and because we don't know the angle in the calculator, you have to do the inverse, which is second tangent. Type in 6 divided by 4, and then rounding to the nearest degree, we get 56 degrees.